All right, awesome, awesome. Well, thank you all again for being here. My name is Eno. I'm the co-founder of Global Air University. And before we really get into it, I want to just do a quick introduction. I have a few slides I'd like to show you just to introduce you to who we are here at Global Air U. And then we'll get into the core mission of today, which is our drone repair and maintenance training. So if you can all see my screen, I think you should all be able to see it. Yeah. Awesome. Yeah, so again, thank you all for joining us. This is the first of a series of trainings and webinars that we're going to be doing on behalf of Global Air U. And we're going to explain to you our story, our history, how we got to this point here. But we are a company, a drone company based in Baltimore in the USA. And we also have a branch office where I'm actually currently located in Lagos, Nigeria. So I'm actually joining you all on the East Coast. We're about 5 hours here, 5 hours ahead in West Africa. And I believe we have some folks from East Africa, Central Africa as well. So I know we're all over the place. So just excited to be here with you all. So definitely feel free to check out our website. Of course, we have a ton of information there at www.globalairU.com. And you can learn more about the projects that we've done and some of the awesome courses and materials that we have coming up. We are very active on social media, which is maybe how you find out about this program. So feel free to give us a follow at Global Air U on any of these platforms. You can also find us at Global Air Media, which is our parent company, and GA joining. All right. So just a quick story on who I am, and just to give you a brief introduction on how we got here. So my drone business journey started in 2015, and for those of you who may know my story or may not, but back in 2015, I saw drones being used in a number of different industries. Of course, we all saw the Amazon delivery video that first came out. It really sparked interest in what this technology could do. I was actually in Nigeria, where I am now, and I saw a drone being used to film an outdoor event, and this was back in 2015. So I was really just blown away with where this technology was. And after I did a lot of research to find out how many different industries were going to be using drones, it was a no-brainer for me. I was in a different industry at the time. I was into construction and project management, and I wasn't really fulfilled. And it wasn't really my passion at the end of the day. So when I found out about drones and I learned all the different applications, I was hooked. And from there, you can see from these photos, how much we've been able to grow, over the years. I've personally been able to do drone workshops now in 13 different countries. I've met all different types of people from all different, backgrounds. So to be able to spread this knowledge is very impactful. And what I'm most passionate about is giving this knowledge back, right? We've had a number of years in the industry, but what gives us the most satisfaction is to pass along this information so you all can be empowered, can start your own drone businesses, and start your own drone journeys as well. So that's why we're here, and that's really what I'm using all my experience to give you all. So of course, I am an FAA certified drone pilot. I first got the license when they came out in 2016, late 2016. And since then, we've been, really taking full advantage of what the license provides. Of course, the FAA is the gold standard when it comes to regulations and operations in the drone space, and many other countries reference the FAA as far as the licensure and procedure. So there is opportunity. It's not just only for US citizens as well. So there is an opportunity for foreign nationals also to obtain the FAA pilot license, and we'll get more into that detail later on. So just quickly on the distinction between our companies and really the journey to get here. We first started out as Global Air Media, which was our for-profit company, where initially we were just mainly focused on providing services with drones. So agriculture, construction site mapping, real estate photography and video. This was really the low-hanging fruit for us, and where we got the most traction in the beginning. And after being in the industry for a number of years, realized that the industry wasn't going to grow at the pace that we all wanted it to unless more people genuinely understood the benefits of drone technology, how to get involved, how to start your drone business, et cetera. And we also knew that the next generation, the ones that will come after us, of course, they have to be empowered as well, and learn about the fantastic uses of drone technology. So when we realized that, we started Global Air Drone Academy, which technically is our nonprofit, which we use to mainly teach youth, young adults about drone technology. We do a number of business coaching and business competitions to help more youth get involved. And after we had Global Air Drone Academy, or GATA, as we call it, for a number of years, we realized that we needed something that was more focused on adults, right? And the adult training and the adult experience when it comes to drone technology. So that's how Global Air University came about. So the distinction between Global Air Drone Academy and the university is that the university is specifically for adult training. We focus more on deep applications and deep knowledge when it comes to drone technology. So we do have a ton of resources for you at Global Air U. We're excited to share our knowledge and our experience over the years. Some of the courses that we have, you can see here. I'll explain more towards the end, but just wanted to introduce you to some of the courses that we've been developing over the past several months. And again, our goal, our aim is to put all this material into this concise course so you can learn and benefit as well. So lastly, if you need anything regards to industry-specific training, of course, online learning, consultation, entrepreneurship and business coaching, and of course, youth programming is all what we specialize in. And again, we're just really, really excited to be able to spread our knowledge. And we are here, as a resource. Lastly, I will mention that we do have a Facebook page. We have a normal Facebook page, and then we have a private group actually called Drone Business Masterminds. So if you are interested in communicating with a private group of drone entrepreneurs and enthusiasts, I would highly encourage you to look up Drone Business Masterminds on Facebook. This eventually will turn into a paid community. Everyone who purchases a class or takes a class with us will automatically be entered into this private community. But we do intend to use this for all types of networking, again, amongst drone entrepreneurs and enthusiasts all around. So with that, again, just wanted to give you a quick introduction to Global Air University and all of the Global Air entities that we have, and a little bit about our backstory. But of course, today we are here to talk about drone repair and maintenance, which is a course that we actually have coming up very soon. And one thing that we believe at Global Air U is bringing in and having our experts on the line to cover these specific subject matters. Of course, everyone has their expertise, be it business or drone building and manufacturing, FPV drone racing. There's so many different niches that you can go into, but we're actually very, very fortunate to have some really, really awesome drone professionals with us today to help us go through some of these topics, right? So this is a open-ended session. Of course, we want to hear your feedback. Oh, is the audio? Can you guys hear me? Someone said the audio is not good.
I can hear you just fine. I don't know about others.
Yeah, I got you. I got you good. I can hear you just fine.
Okay. All right. Appreciate it.
Okay, hear you.
Thanks. All right. Yeah. If any issues, yeah, just pop into the chat. But yes, this is definitely a open Q&A type of session. If you have any questions on the topics that you're going to hear us talk about and discuss, please put them in the chat. We will have some time at the very end as well for you to ask any questions that you want. So with that, I'm actually going to first call on our friend Graham, and I'm just going to actually introduce Graham properly. I have a Graham. All right. Yeah. So first off, Graham Newton, we've known each other for a few years now. Graham is originally from South Africa. He's been experienced in the commercial aviation industry since 2010. He's a pioneer in the remote aerial surveying and cinematography field. He's built, tested, and refined drones and camera gimbals. He co-founded Skyhook in 2012, which was providing the film industry with high-quality aerial video and photography. A lot of experience in design and manufacturing custom unmanned aerial camera platforms, as well as stabilized camera heads as well. He's done a lot of experience also in consulting, aviation policy and compliance, development of required documents and company infrastructure. He also received civil aviation certification to provide professional services some years ago as well. Lastly, he's very diversified in aerial data collection, survey, and security industries. And again, we're just really excited to have Graham with us to talk about his experience, with drones, everything that he's been able to learn and accomplish, over the years, and of course here to network with us as well. So Graham, welcome to the session.
Thanks, Enno. Hi, everybody. Thanks for that nice introduction there. Yeah, it's good to be on board here. So I'll just should I just give a little bit of background on myself beyond that, or do you want to roll into the questions?
Yeah, you could just any background you want to give, and then we can go to the questions from there. Yep.
Yeah, so just I've been at this for many years. I started playing with radar controlled stuff when I was like about 6 years old. My dad got a glider and we built it up and we learned to fly, and he had learned from his father before him. So it was definitely just keeping it in the family. So it's in my blood for sure. I've got a passion for aviation and engineering. Manned aviation was always a bit inaccessible living in South Africa. It's just too expensive. So I jumped into the RC world to get that, to get my fix in sort of flying and engineering from the RC world. So yeah, I started designing started with airplanes, designing planes and gliders, old engineering drawing boards, building them up, learning to fly that way. At the time, there was hardly any electric aircraft around. It was all nitromethane, because there were no brushless motors and lipos yet. So it was all, the electrical wasn't really practical at all. I took a bit of a break during high school when there were other more interesting things to do. And then I went on to study engineering, got a mechatronics degree, and during holiday, one of the university holidays, I pulled out the little airplane and I started flying it a bit again.
Battery 50%.
I was doing some downhill skateboarding at the time, and there was a big scene, culture of filmmaking. So I dusted off the plane, put a GoPro onto it, and then chased some of my friends down a mountain pass with the plane, which was really fun. And that definitely, it exposed me to the aerial photography, videography world. And from that point on, sort of took over my life totally. So then I started building another camera plane. But after enough rough landings, I realized that I needed something VTOL orientated. So I started building a hexacopter. I don't know if any of you know the KK boards. They're one of the first flight controller boards. I had to strip some gyros off a Hobby King gyro, solder it onto the board, get that flying. That eventually crashed because it's a learning curve. I didn't have any voltage regulation or any capacitors on the voltage. So there was a voltage spike and it reset the board in flight. The thing crashed. So you learn the lessons like that way. Then I got a more advanced board. Still no GPS on these boards. And then if anyone knows Pilot or Copter, that's another. That's a very sort of industry known open source autopilot. So I've started getting those boards, try to learn how to tune the GPS and PIDs on those. Then I started building bigger X8s, which is a coaxial octocopter. So it's like a quad with coaxial motors, like 14-inch props on that to carry Canon DSLRs. And then in parallel was designing and building the camera gimbals, trying to push the limit of the stability of the camera using standard RC servos. Got some high-speed heli servos, belt drives, large gear ratios to minimize the effect of the steppiness of the servo, so it was a nice smooth movement. So all this sort of stuff I learned along the way, and then culminated with building a big 40-kilogram all-up weight X8 with 27-inch props. So that was one of the nicest aircraft I built so far. Yeah, that's a good background. So I'll hand it back to you.
Awesome. Yeah, no, thank you. Obviously, I have a lot of experience and okay, let us some people in. All right, so yeah, just a lot of experience there. So I guess my first question is, let's maybe start at the basics, right? Because I know a lot of people here are interested in general repair and maintenance, but when we talked before this session, you said the main thing is understanding the mechanics, right? Before you even get into how to repair, how to maintain your drone, is really important for you to understand the basics and the mechanics. So where would you kind of start in that whole process? What are the kind of the basic mechanics of drones? Assuming we have some newbies, here as well. What are some of those kind of basic components and things that someone should know?
Yeah, so I think you can start with your airframe, what you're looking at building, and the materials that you're going to use. So industry standard is carbon fiber for its lightweight to strengthen rigidity. Obviously, rigidity is key for the airframe. If you've got a big sloppy airframe, you're not going to be able to tune it you're not going to be able to increase your PID, your gains up. So you're not going to have any sort of crisp flight performance. It's going to be big, sloppy, wallowy aircraft that won't look nice and it won't give you good results. So designing your airframe and keeping in mind that you're going for that rigidity. So then you can look at other important components. Obviously, the battery, very important. You want to size the battery correctly for the application for your, and you want to look at getting the right voltage and C rating for the battery. So I don't know if people know about what the C rating is, but it's essentially the ability to discharge. So how much current you can discharge, what percentage of your voltage, your battery capacity you can discharge continuously. Motors, obviously, very important things to look at with motors is your KV is the most important. So that's essentially going to tell you what is your no load RPM for a given voltage. So if you're running a 6S system, so 25 volts, and your KV is the 1700 kV motor, you're going to have you times 1700 by 25, and that's going to give you your no load RPM. And then you need to match that with your prop size. So if you have a too big a prop on a motor that's trying to spin too fast, your motor is going to overheat and you're going to have trouble. You're not going to be efficient, and you might burn something out. On the other side of the spectrum, if your props are too small, your motors are going to be spinning at their maximum RPM, but you're not going to get the thrust that you require. Different types of prop. There's obviously the high end would be a carbon fiber composite, the balsa core, and those are really nice props, super light, but they're very expensive. Then you can go all the way down to like a wooden prop or plastic even. So it's always that trade-off between weight, performance, and price that you're working to find a nice balance. other important spots are the speed controls. So you want to look at sizing a speed control that's going to be within your voltage range. So, if it's a 6S system, you're not going to get a 4S speed control. And then probably the most important would be your current capacity. So if your motor can pull, say, 30 amps, rule of thumb that I use, I would get a minimum of a 60 amp speed control, so you can handle any current spikes and you're not going to damage the equipment. Then moving on to the heart of it is your flight controller. There's obviously multitude of options to get different flight controllers. You want to look at what software you want to run primarily. So I mentioned before, there's the ArduPilot range of flight controller software. You can have ArduCopter, ArduPlane, and then obviously for the more FPV oriented, there's like a Betaflight, and then iNav is somewhere in between there. So you sort of need to look at it and see what's your end goal and what is best suited. And then that's on the software side. On the hardware side, you can go for really like high end, probably the high end, and the industry standard is the Cube from Profi CNC. They're based in Australia. They got some really cool hardware. They're like triple IMUs, heated IMUs, 5 damp IMU on board, all sorts of stuff like that. And then going along hand in hand with the flight controller is like the sensors that you're going to use, right? So you're going to have a basic operation. You can have a GPS and a compass, your electronic magnetometer. That's for navigation, and then you can get more into it, and you can put a LiDAR on for range finding, for your longer missions, so that when you come back and land, if there's any drift in the air pressure, your aircraft knows where the ground is. You're not going to smash into the ground because you think it's 100 foot below where you are. And then you could look at putting the compass, if it must be built onto the flight controller or mounted externally, and why you do that with magnetic interference from your motor wires, power supplies for your flight controller, and then obviously very important is the communication. So you're going to have an RC controller, and you might well have a telemetry system too, so that'll run by depending on what flight controller you have, but Mavlink is the standard. So you're going to get your telemetry sent back down to the ground station, so you can monitor voltage, current draw, flight mode, distance from home, altitude, all that important stuff. Those you're going to look at what frequencies you're going to use for to operate on, and what is the power of the transmitter. And you want to obviously stay within the legal boundaries, so you're not going to get something that's way too powerful. I believe on a 2.4 gig spectrum, you're only allowed up to 100 milliwatts. Anything more than that, you need a special license to operate. And then obviously the payload, which is why you're flying the aircraft, is a camera, is it a sensor, is it a multispectral camera, is it a gas sniffer, is it a light, anything like that. So those are the basic things that we think about the mechanics of the drone.
So obviously there's a lot of different ways you can go. I mean, when you think about the airframe, of course, that's just one kind of component, but it really comes down to what your application is, right? I mean, are you using it for just photography? Are you using it any type of special sensors? Are you using it for delivery, so on and so forth? So what would you say are the typical type of drones that you have built? Like your entire kind of experience? Has it been more like fixed wing drones or more kind of quads? What have you kind of tended to build more?
For the commercial operations, most of the stuff that I built's been multi-rotors. So generally, quad or a hex or an octocopter. I haven't built anything with more than 8 motors yet. But between those, you find a compromise for redundancy, safety, performance, efficiency. You see which best fits your application. Fixed wing obviously is very important, and going forward, there's a lot more aircraft are becoming fixed wing, and then VTOL. So there'll be a hybrid. Those are already for mapping and inspection and agricultural applications. The VTOLs are really taking off. They're becoming a very important part of the sector.
Yeah. So yeah, VTOL, for you all who may not be familiar, is vertical takeoff and landing, and the biggest difference from traditional, shall we say, fixed wing is the ability for the VTOL to take off vertically and not have to use a catapult or any other runway and things like that to take off. So we've definitely seen a lot of good applications for that. Now, before we get into some of the repair maintenance type of questions, obviously you're working directly in the drone industry now. I know a lot of people on the call are wondering, what do I need to do to get into the industry? What kind of skills are needed, both on the entrepreneurship side and, from the normal labor side as well. So where do you see the jobs in the industry right now, and what are the skills that you would say that are necessary to secure a job in the drone industry like today?
It's a great question. Obviously, most people when they see drones, they think filming, which is how I started and how I've spent most of my time. I'll speak about the industry in the US. So the barrier to entry for commercial operation in the US is pretty low relative to other countries, South Africa or even UK. They have got more hurdles that you need to jump through before you can fly. In the States, you need your FAA license, and that's it. So there's no shortage of film operators in the States, I would say. So you need to really look at what you can do to set you apart from other people. So that's skills. Like if you're in the film industry, you need those good piloting skills, good situational awareness, but also certifications or capabilities. So you want to look at getting FAA waivers that allow you to fly over people, fly for moving vehicles, or fly an aircraft that's above 55 pounds, that's becoming more and more relevant. Or less and less relevant as aircraft are getting better and the cameras are getting better for their size. So, but yeah, if you want to look at doing more sort of industrial inspection, agricultural work, it's less pilot skills really required because a lot of the missions are autonomous. But you need to, so you can make that up with the skill set to be able to work with the actual payload and the sensors that you're using, know how to use them properly, know how to process the data. And then the other important one is then flight planning and aviation safety, where you will want to, you have this track record and record keeping, and you could, go to a big company. You can say, look, this is what I've done. This is how many flights that I've got. As a company, we have this culture of safety. We operate within these boundaries, and as a result, we have safe and reliable operations. Those are the type of things that set you apart and will allow you to pick up the bigger contracts.
Awesome. And then, of course, when we think about the industry, I mean, the piloting and the hardware and things, that's one area, but, software and all the other supporting, components to the industry, there as well. We always refer to the ecosystem, of the industry. So when you're thinking about careers and things that you can get into, I mean, there's so many different areas, but on the basic, software and hardware side as well, there's so many different, options. So yeah, appreciate the insight. So I guess moving a little bit into some of the core of the maintenance and repair. Of course, you've built, I'm sure, crashed quite a few drones as well. How would you approach? How do you usually approach, drone maintenance? Because I'm sure that comes before, you get a crash. I mean, the point is to do your maintenance to prevent a crash. So we'll get to the repair side. But how do you typically approach maintenance? And this is, of course, for your DIY, the drones that you build yourself, and like a drone like a DJI, which I'm sure most people on this call have a DJI or flown one before. So how would you, I guess, compare, or how do you approach maintenance, and then how do you approach it for those two different type of drones?
Maintenance, key to maintenance is having a prescribed maintenance plan. So back in South Africa, we had to get all our aircraft airworthy by the Aviation Authority, and part of that was having a in-depth maintenance plan and maintenance schedule that we would stick to. So that would be, if it's something that you built yourself, or there isn't that information available from the manufacturer, you got to start looking at the critical components of the aircraft, and how long you feel comfortable using them without, before you need to replace them, or what can be done to maintain them so that they do not need to be replaced. So that's, looking at propellers, making sure they're balanced, there's no nicks and scratches with them, making sure your motors are balanced, the aircraft is not sitting in a humid environment and getting rust. So it's stored in a cool, dry component space. Very important for your batteries. Battery maintenance is huge. If you're starting to do lots of operations, you're going to end up having thousands of dollars worth of batteries, and making sure you look after those batteries and get your, if you can get 150 cycles out of them, or 200 cycles out of them, that'll increase your company profits massively. So yeah, looking after your batteries, looking after the airframe, checking that your nuts and bolts are all tight, making sure your props are tight. That's happened to me more often than I like to admit that the prop has come off, because I just didn't check it. Doesn't even need to come off, just needs to come a bit loose, and the thing will go into the ocean. So just start from a top-down holistic view of the aircraft, and say, what is each component, what do they do, how important is it, and what are the chances of something going wrong, and what can I do to minimize that component failing.
Go ahead.
Yeah, go ahead.
Yeah, so obviously having that checklist, being able to properly check each component consistently, and making your visual inspections. Is this something that you recommend before each flight and after each flight? Maybe when you haven't flown for a couple of weeks? I mean, how often are you actually doing these maintenance checks?
Yeah, so there's obviously your pre-flight and post-flight checks that are part of your everyday operations. Pre-flight would be, before the first flight of the day. And then if you're doing 15 flights that day, you don't have to do full pre-flight every time, but just to have like a couple of items that you check through. Make sure the props are good, make sure the canopy's on, make sure the battery's connected properly, secured, landing gear, payload, just little things like that. And then your scheduled maintenance, as according to your maintenance plan, that'll be done every 10 or 20 hours of flight, or every month or 2 months of operation. And that would be more in depth, really getting down, putting the thing up on the table, getting a torch on it, shining a light on it, and making sure that you're going through that list and making sure that everything is how it should be.
Yeah, at the end of the day, I mean, these are aircraft, right? I mean, these we are drone pilots, so in every sense of the word, you have to treat your aircraft just like it's a manned aircraft to be flying people. So during your checks, I mean, I've personally had a drone just drop out of the air. There was a battery, just like you mentioned, the battery was swollen, and it was placed inside. It didn't necessarily click as it should. And a few minutes later, it was about 150 feet in the air, and the battery just popped out, and the drone hit the ground. So those are lessons that you learn over time. And as much as get into a slightly different topic as far as flying over people's heads, I mean, this is something that we always like to educate people about. I mean, this is stuff that can happen if you're flying drones above people's heads. So that's why these safety rules and things like that are in place. And as Grant mentioned, most of the popular drones on the market today, the DJIs, the Skydios, the Autels, they will come with their own kind of maintenance plan that you can adhere to. But of course, if you're looking to apply for licensure, and especially outside the US for now, they will require you to present, your maintenance plan and how you're going to actually look after your drone. So it's just good practice. We've also talked about a pre-flight safety checklist. If you don't have a checklist, we do have one on our website. If you want to go and download, just www.globalairU.com. Look for the mission protocol and safety checklist. There's a full checklist for you to make sure that you are adhering to that as well. Awesome. So that's maintenance, and then of course, assuming that when crashes happen, you have a choice really to repair it, yourself. If you have a drone like a DJI, of course, there are plans that you can actually send it in to have them replace, the drone for you. So when it comes to these repairs, again, just like the maintenance, I guess, what's your general approach or like that workflow when it comes to, the diagnostics and how you go about it? And then also if you can touch on like some of the common repairs that you see.
Okay. So if you look at sort of what you need to do for the repair, it starts with a disassembly, or starts with an assessment of essentially what has been damaged. And you got to make the determination: is it worth repairing this, or am I going to write it off? Am I going to send it back to the manufacturer to repair? If in many cases, it makes sense to send it back, but maybe you're somewhere in the world that you don't have access to a good repair site, so you got to do it yourself. So you want to look at what is damaged. Generally, props are going to be damaged. You're going to have props and arms. Those are the most common things to go. Sometimes the motor, the bell is going to be dented in, so it's rubbing against the windings on the inside. So you're going to make a list of, as you disassemble the aircraft, make a list of the components that are damaged that you need to find. So first step would be getting online and ordering those parts and making sure you can get them. Otherwise, what's the point of taking it all apart? The last thing you want to do is take the whole thing apart and then find there's one component you can't get, and then the drone sits in pieces and stuff gets lost and you forget how to put it together again. So you want to make sure you have all the tools, all the components, before you start really in earnest. Disassembly is making notes is critical. Take photos, making notes, and then being very careful when you disconnect plugs and wires, like those little antenna wires, the MMC connectors. You got to be very careful. If you bend them too much, you'll damage it. And once you damage it, it's not. It might look fine, but it's damaged on the inside. When you get it up flying, then you realize you got to take the whole thing apart again and start again. So you want to be very careful with that. And then one of the most common issues is stripping the heads of the screws when you're taking them out. Most aircraft that use a lot of Loctite to hold everything in place, which is a good thing, and you should do that. But you can find a situation where you don't give enough force and you end up stripping the head of the screw. So that's probably the most common thing that's happened to me. And there's ways to get around that, but none of them are pretty, and generally include metal filings all over the place. So so that's assembly, and then you want to use a good multimeter. So once you've got it apart, you can test the components, test if they're working, if they're like individual components of taken a hit, if they're broken, stuff like that. And then you can get into soldering and that sort of stuff, or we can maybe say that.
So as far as DJI is concerned, of course, again, a lot of people here, I'm sure, have DJIs. I mean, and we do want to also note when, it's important to keep in mind the warranty that you have as well, because DJI is very particular. When you open up your drone, when you actually start that disassembly process, you can actually void your warranty. So you do want to be careful when you are planning to work on your own drone. But the DJIs that you have worked on, would you say it's generally not easy to disassemble, but is it kind of like modular? Do they make it kind of easier that, you know, someone could do it is something you really have to actually like learn. Yeah.
It's in my experience, the smaller drones are easier, but if you look at doing something like an Inspire 2, those are incredibly complex to take apart, because you can strip it down all the way, but there was, you know, one little screw hidden somewhere that you didn't know about, and you're trying to pull the thing apart, and you can't get it apart, and you're wrestling with it. So yeah, Inspires are pretty complicated. I think the easiest one around is the Phantom. Phantoms are pretty simple. And then, yeah, like Mavics after that are getting a little bit more complicated up to the Inspires. So you want to take your time. You don't want to rush it. You want to take photos and notes of everything, and you're going to take off so many different screws, and you're not going to know where they go. So you want to compartmentalize every little screw, or the sets of screws, write on them where they go. So you make sure when you put it together, you don't have anything left over. One screw left over is acceptable, but no more.
Yeah, and I think, you know, that picture taking is very, very crucial as well, because yeah, you don't want to, you know, remove a screw or remove a wire, and then you're wondering, oh, you know, where does this wire go? So yeah, documenting everything, taking notes, if you are going to be repairing things like that. So yeah, this is some great info, and please, guys, if you have any questions, put them into the chat. Just lastly, did want to get ready for Alex as well, but just wanted to ask Graham about fleet management. And I know there's some folks here who maybe have multiple drones, you know, 5, 8, you know, 10 plus drones. What would you say is your general approach to how you manage these drones? Of course, there's some type of protocol or checklist. We talked about maintenance and things, but yeah, what's your general approach to fleet management? And if you use any software to help as well, would be helpful.
I haven't used much software in my operations for fleet management. I know there's a vast amount of them available, so we can dig into that. But I would say, yeah, documentation is key. So, you know, treat the operation as if it's a CAA certified operation, and make sure you have your maintenance manuals, your flight logs for all the aircraft, log how many flights you've had on each battery, how old the batteries are, stuff like that. Because the battery is such a simple thing just to write a note on it, and you know, if your battery goes, you're in the dirt. User manuals for every aircraft. Make sure if you've got multiple pilots operating them, that they're all up to speed with that specific aircraft. I would also say, like, try and limit the amount of diversity of equipment in your operation. So there's not, you know, 10 different types of aircraft that, you know, people have to understand and remember how to fly. You know, if you keep it tight, keep it all similar, that will definitely help a lot. And then probably the most important is sort of instilling a culture of safety in the operations. So that's like, you know, logging everything. If you see something, if something happens, make sure it's reported, write it down, and then that provides an opportunity for the other people in your operation to learn from that experience. You know, something happened, oh, that was bad, wow, it could have been bad. Write it down, tell people about it. Then the next time it happens to them, say, oh, I remember, and we've discussed what to do about this. Then you make sure that, you know, that's the sort of the safety culture that is important and really will save the bacon. Yeah, I think those are my main points on that.
Yeah, well, you know, the theme is really documenting, you know, the process. Well, first of all, making sure you have a process that you can, you know, document. Make sure you have your checklist. You know, make sure you're performing these routine checks. And it really
routine is a great word.
Mm-hmm, yep.
Routine is
making
a great
sure it's,
word.
you know, normal for your process, and things, you know, will go relatively smooth. So yeah, so this is the type of you know, information, of course, that will help, you know, your operations. And you know, the idea for the full course that we're offering is to really go in depth, you know, on some of these topics, and really get into yeah, what it takes to have a manageable fleet in order to and have the ability to repair and maintain your drones over time. So really appreciate the insights, Graham. And if anyone has any questions, we're still going to be here a little bit, so we'll save some time at the very end for those. But with that, we're going to thank Graham for being here with us. He's going to stick around, hopefully for a little bit to get some questions. Just want to go ahead and introduce Alex Suarez, who is a GATA, former GATA instructor, now working with us at the university as well. All around drone enthusiast, drone extraordinaire, globally ranked FPV drone pilot, has built countless drones, I'm sure. But of course, Alex is really specializing in the FPV, the first person drone space. So really honored to have him with us today. And just Alex, just want to give you an opportunity to just introduce yourself, tell us a little bit about how you got into the drone space. And really, I'm interested in hearing, how did you decide to maybe not segue to the traditional commercial aspects? What made you go right into FPV?
So thanks for that. And so it's Alex Suarez. So I started off about 2012-ish with drones in general. So I started off with fixed wing planes, got it at your local hobby store. So that progressed into quadcopters because I learned I couldn't fly planes well. So then I saw quadcopters. Those were a little easier to fly. I saw that you could build them, so I started building them. And then next thing I knew, you could race them. I started racing them. So racing has led me to do things such as qualify for the global championships. I'm currently a college student in which drone racing also has allowed me to compete at the collegiate championships, which I took third in this past year. And so I've been building racing drones for about 5 years, and I've recently got into designing them and just generally sticking to that. And since I started with FPV before I got into the commercial side of things, that's more so why I've stuck in FPV and not really left for as much commercial side of things.
Awesome. So what would you say is the biggest difference between, traditional drone and the FPV drones?
So your traditional drones, most people would think of a DJI aircraft like the Phantom series or the Mavic series, the Inspire series. Then there's the more specific commercial drones where they're used for like the Alta for filming movies or just inspections. There's delivery drones. Most of the thing that is a way that those are categorized is they have a lot of autonomous features and they assist the pilot in operating the drone. You don't necessarily have to control every characteristic about it. You just control a few things and it sort of holds the drone where you want it to go. With FPV, it's a little different because the drone doesn't have any stabilization, really. Every input you make corresponds to an exact output, and it doesn't auto level. It just keeps whatever position you put it in last. So you have to constantly update how you're controlling it, and this is called manual control or acro mode. And so this basically takes a lot more effort and skills to fly them, just generally because you're always paying attention. You have to learn the memory of the drone of what happens when you're going to go here. Say you spin around, you get lost, or you crash into something, your aircraft's spinning around. You have to actually figure out yourself how to get it back stabilized versus the software figuring that out and stabilizing it for you. So as well as with FPV, you're flying another big thing with that is you're flying with from the perspective of a camera on board the drone. So you're wearing goggles that show you exactly what the drone sees and you don't see anything else. All you see is the picture from the drone and that's how you're flying. So you're flying using a two-dimensional image in a three-dimensional space.
Now, obviously, to the layman, it sounds a little difficult. I mean, how would you explain like the learning curve to learning to fly, the traditional quadcopter to learning and being proficient at an FPV drone? What does that difference look like?
So there is a little bit of a learning curve, depending on who you ask. Some will say go straight to learning manual mode. Some also understand that most people will learn with an auto level aircraft first. And going from auto level to manual mode, the best way to start with that is probably to get a simulator. And the simulator will basically mimic almost exactly how the FPV drone will fly in real life. And you can crash it all you want and it doesn't break. And it's a lot less expensive. You don't have to worry as much about if you break something, you have to buy parts to repair it. And then after you get maybe 10, 20 hours in the simulator, you're probably going to be good enough to go out and try flying an FPV aircraft in real life. That's a little more daunting, but you'll realize that you'll have a little bit of the muscle memory from the simulator, and it generally comes fairly naturally after that.
So the simulators are, because I mean, we've all heard maybe the simulators sometimes aren't as accurate. So you think they work pretty well? It's a good starting point.
So FPV simulators are very accurate, mainly because there's a large community behind them and actively saying, this simulator doesn't fly well, fix it, and the company fixes it.
Yeah, that makes sense.
And
You
so,
use the feedback.
So they've built up the simulators. Now they fly almost identically to real life. Some people purely race in simulators and they've never flown outside, and they'll do online competitions. And then when you see those pilots go outside to fly for the first time, it seems like they've been flying for years just from a little bit of simulator practice.
Yeah, so just from a simulator, you can learn before you even go out and spend that money on a full kit.
Yep.
Awesome. So similar to the question I asked Graham, what is your approach to building these type of drones? If you can maybe touch on some of those main components as well, and then what your general approach is for how you choose to build your FPV racers. I know there's different type of racers as well, so I know that goes into it. So how do you approach that?
So the components are going to be almost the same as what Graham is using, just on a different scale. So our props, our propellers, they break so often. Carbon fiber propellers are not worth it, so we use polycarbonate, which is a type of plastic. And so that's going to be that. Our motors, they go hand in hand for both of them. Flight controllers we still have. Our electronic speed controllers we have. Now we have receivers and our communication links. Now something that isn't necessarily going to be on one of those commercial aircraft is we have our video transmitter, and this is designed for a low latency transmission of the video signal. So by low latency, we're talking less than 20 milliseconds. So it's difficult to notice for most people. And so that allows us to get the precision we need when we're flying at 80 miles per hour through a tiny gate.
And a latency, that's pretty much the time it takes for the signal to reach your goggles.
For the picture from the camera to the lens to the screen on the goggles.
Yeah, so obviously at those high speeds, very, very important to have that low latency. What would you say is the fastest you've ripped the drone?
Legally 100 miles per hour ground speed.
That's a good answer. Good answer. Yes. Legally,
But if I were,
yes.
yeah, if I was indoors in a large open room, I could probably reach over 100 miles per hour. But
Um,
yeah.
yeah. No, that's awesome. So what is the future of drone racing look like? I mean, we've seen some of the, events. NBC is running, the DRL. There's so many more people getting into the sport right now. Where are we looking for drone racing in the next 5 to 10 years? What does that look like for you?
So I see drone racing as it's still growing. It's becoming bigger and bigger. There's over 30,000 pilots, drone racing pilots registered in the world. And there's races every weekend all across the world. I see that to be growing, especially now that COVID's declining. More people are back outside and getting into things. And so a lot of now, the one thing that has slowed it down a little bit is recent regulations. But other than that, most people would say it's still growing and becoming bigger and bigger because it's becoming more accessible to people.
Now that you talked about the regulations, maybe you can just maybe do a quick note on remote ID, because I know that's for those of us in the States, it may be a little vague on what remote ID is and who has to use it and when is it being, and there's dates being pushed around. So, there's a lot happening, but Alex is also head of government affairs at Multi GP. So he's on the front lines, when it comes to, regulations as it relates to recreational FPV pilots. So yeah, maybe tell us a few about what remote ID is, why they're presenting this, and how does that affect specifically drone pilots in the U.S.
So in the United States, remote ID is essentially what the FAA considers a license plate in the sky. It is supposed to be used to identify where an aircraft is flying and its operator, and who that operator might be, to increase situational awareness for law enforcement officers and other people in the surrounding public. And so there's 3 forms that the FAA has created for remote ID. The first form is what's called standard remote ID, in which it is built directly into the drone. So this is what manufacturers who's building your drone, like DJI, Skydio, are going to be putting into the aircraft, that transmits the aircraft location, pilot location, the time, and then a couple of other different information, a session ID. And this session ID can be used for law enforcement officers to go to the FAA, who then go and see who is flying if, say, something's going wrong. So say there's a no-fly zone for a football game, and someone takes off and tries to fly near it. They can see that there's this drone in the air and figure out where the person is and who's flying the drone to determine what's going on and actions to take to prevent things from happening in case something were to go wrong, and just increase the safety of the national airspace system. Then the other second form of remote ID is what's called a broadcast module. This is designed for educational, home built, recreational pilots, and older aircraft that don't have standard remote ID built in which instead of showing the pilot location, it shows the takeoff location of the aircraft, along with the same data that the standard one closes. Now, what's nice about this one is it can be assigned to multiple drones. So you can have one module and transmit it between multiple aircraft for recreational or educational users. Commercial users still have to have one per aircraft. Then the third option is if your drone isn't capable of remote ID and you don't have a broadcast module, there is what's called a FRIA, which is a federal recognized identification area. And this is basically a space where a club, an organization, a community-based organization would, or educational institution would say to the FAA, we'd like to fly in this area, and the FAA would designate it as a FRIA, where all aircraft flying in this space wouldn't need remote ID. This is more so for those aircraft that physically can't put it on there. So say they're smaller aircraft where it just would decrease the flight performance, or it's very old and it's hard to modify to add the broadcast module, stuff like that. So yeah, that's basics of what remote ID is for and what it is.
Yeah, no, so this is, very relevant for those of us, that will be flying in the States. I can imagine that this is going to be pretty standard for other governments, for other CAAs eventually as well. So, this is, we're going to look back on these times and say, wow, this was the Wild West, when we didn't have any remote ID and anyone can just fly, anyhow. But these changes are coming. But at the end of the day, I mean, this is I believe it's positive, for the industry, as much as some of the recreational pilots may not think so. But I think it helps increase the safety standards, which helps more applications to be explored. If we don't have any safety measures in place, we can't really expect these applications to grow. So I really do appreciate the insight on that. So we're going to spend the last couple minutes here just having any questions and answers. We've had a lot of fantastic information. And just a side note, we will be putting a replay of this session onto our YouTube page. So if you're not following us on YouTube, feel free to go to just search Global Air University on YouTube and subscribe. You'll see when we post this video here. I'm also going to put some timestamps so you know exactly at what point we talk about certain subjects, and you can go back and watch it there. Also, if you're not on our email list, make sure that you go to our website, www.globalaru.com, and sign up for our emails. We'll be sending out information, our free resources, replays, and we send out weekly emails regarding drone tech and business and everything in between. So please, if there's any questions anyone has, ask now, and you can pop it into the chat if anyone wants to raise their hand, and we'll get some questions in. And I guess I'll kind of start off with Alex and then Graham. I mean, Alex, if someone wanted to get started in FPV, what does that starting point look like? Is there a certain site that someone would go to? What does those initial first steps look like?
A lot of YouTube videos. So there's a lot of information out there, a lot of creators who specialize in creating content on building and troubleshooting FPV drones. Most of that is on YouTube. It's easy to access and very well made. There's also forums online. So there's different pages. Yeah, Joshua Barbell videos. Then there's forums online. They're like Race Day Quads has their forum. Facebook groups. There's a lot of Facebook groups that are good for this. And then, so there's a lot of resources out there. Quick Google search. You could even look drone racing, and then wherever you're from on Facebook, see if there's a group near you or if there's pilots near you, or maybe look at some of the bigger hubs near you if you're out further from a hub, and you might be able to find some places and get some local help.
Definitely. The community groups are very important. Also, I'm going to plug in our drone business masterminds group. As the name implies, it's more for business, but we do bounce questions off of each other regarding, building and FPV racing and everything in between. So it is a private group that you should be interested in to join up. But yes, community groups are very important. YouTube, I always say, YouTube University is a resource for you. So definitely go out there, learn. And we are planning a separate course with Alex as well. So if you are interested in learning in detail about FPV drone racing, we do have a course that will be coming out, and make sure we stay in touch on email regarding that. So so appreciate that. We have a question here. It's probably more for Graham, but someone's asking, do you see any need or use for independent DJI repair operations? So I guess he's asking, is there, in a sense of setting up a company? But yeah, Grant, what would be your response to that?
It's a good question. I think response would be, it depends where in the world you are. It depends on how easily you can access like a certified DJI repair shop. And then the other question is, do you want to do it? I know that, if you went that way, you could get certified by DJI itself to be a repair shop. So that's the other option, versus just doing it totally independently and finding the components off, online and buying them. If you buy the components through DJI for the repairs, they're going to be cheaper, so your profit's going to be bigger. So if you were really going that full repair route, it would be wise to investigate doing it as a part of DJI or affiliated with them. That would be an answer. And if that's not an option, then sure, go ahead and do it totally independently.
Yeah, I know, typically DJI, if I'm not mistaken, you have to also be a distributor, an official distributor as well, to be certified as a repair center. So of course, yeah, that ticket to entry can be pretty high. So yeah, just again, as Graham mentioned, it depends on where you are, if you have, readily access, to the materials. But I can imagine, if you're in a place where it's not easy for one to just send out a drone, and if you have the parts and you have the repairs, you have the experience repairing, then yeah, that could be a good business case, potentially. And one of the things that we are planning to talk about during our full course is that business process, how to actually set up a drone repair business, assuming that you're in a location that it will be feasible. So appreciate that question. I hope we answered your question as well. Next one we have, must one read engineering to be able to repair drones? So I guess they're asking if one has to kind of do like an engineering course in order to repair.
It's obviously useful and you learn skills, but generally the engineering, like an engineering university degree, is more theoretical than practical. So I would say that if you're looking, if you wanted to go that way, doing sort of more technical courses where you learn how to, work with the hands, work with the tools, all that stuff would be better suited to like a pure drone repair skill set.
Yeah, especially if you plan on going in the depths, of the skills needed to repair and replace. Okay, we have another one here. You guys can feel free to put them in the full chat as well. We have some that are direct messaging, but we have a question about software. I guess this is really getting started in. Talk a little bit about the airframes and that base kind of structure. So yeah, what type of software are you using, and is there any other special equipment that you're using to put together an experiment with these airframes?
Yeah, software obviously is if you're designing from the ground up, you're going to need a nice CAD software. The ones I've used are Inventor and SolidWorks and Katia, but those are all, very expensive. It's like $400 a month for a subscription, which is an overkill for what we would need here. There's some free ones out or trial ones, but you get a bit frustrated with the limited functionality. So my recommendation would be go for something like an Onshape or Fusion 360, where it's a small monthly cost, but you have all the functionality that you need. FreeCAD is decent. Yeah, I haven't explored the free options too in depth, but yeah, that would be my don't go free, because you might get quite frustrated. So if you're doing it properly, it's worth spending a little bit on. That would be my recommendation there.
All right. Okay, we have I guess a follow-up to the message. So Gene is saying, okay, Missouri DJI requires the distribution component. Yes, so they do require distribution and $100,000 revenue for application consideration. So yeah, there's a pretty substantial barrier to entry if you do want to be an official DJI distributor. So yes, clearly, if you wanted to do the independent route, your target would be, people who their warranties have run out. For some reason, they don't have a warranty or they don't have insurance. They really don't have any other options, So there is a way I think you can target, those individuals. But again, you want to be able to give them the best service. Any other questions? We're about to wrap up soon. I did want to also mention, as we are waiting for any last questions, of course, we have our drone repair and maintenance course that will be starting next week. And we have some spaces that have already been filled. So if you are interested in learning more about these topics, we wanted to, of course, give you an intro or brief on what to expect during the full training. In addition to learning from our experts, you will have access to checklists that we have prepared for this course. We will also have some maintenance manual samples as well. I really want you to be able to walk away with this course with all the resources and tools you need to feel comfortable and with your maintenance schedule, fleet management, and repair as well. So a lot of good information coming. Hope to see you all on that course. And we will be doing more of these trainings as well. Our goal is to do at least one of these a month, if not more. We do have a lot of requests for different subject matter. I can say that next month, we're going to do one of these for drone cinematography and really get into the depths of what it takes to be a drone cinematography pilot. So yeah, let's look forward to sharing more resources with you over time. Any last questions before we wrap up? I do really appreciate you all. And here, let's see if we missed anything. All right, so we have a IG page here, Mr. Navarro. So make sure you follow him as well, the Escape Velocity Coach. All right, so make sure you hit him up on IG. Make sure you're also following us on IG at Global Air U. Let me see, any more questions? All right, yeah, shout out to Kevin as well, joining us from Kenya. I know it's actually pretty late there. It's past 12, so appreciate you joining us, Kevin. Kevin's also a very avid FPV drone racer as well, so we look forward to collaborating for more events. But yes, so yes, I will share the recording. It's going to go right onto our YouTube page. So most likely tomorrow or very late tonight, I will send an email with the recording. And so you guys can go back and watch. And like I said, I will make sure that I have timestamps so that if you want to go to a specific section that we talked about today, you can go right there and enjoy. But yeah, this is looking like the end of this first webinar training. I thank you all so much for joining us. I hope that you learned a lot today. I hope you got some value out of today's session. If there's anything else you want to see, let us know. We are here to provide as much resources as we can, to help you along your drone business journey. So feel free to reach out to us on any of our platforms, and we'll be in touch for the next training. We hope to see you all, for you all that are joining us next week for the repair and maintenance training. So thank you again, and look forward to seeing you all next time. Thanks, Alex. Thanks, Graham. See you guys. All right.
Bye. Thanks. Thanks, Dino.